Hello class, and welcome to the start of Unit 5. So today we're going to take a look at, in this unit we're going to start taking a look at transferring algebra to quadratic functions. I know we just did a quick Unit 4, and that Unit 4 just kind of introduced the quadratic and the different forms of the quadratic and transformations of the quadratic. We will come back to that information after we do the algebra part. We're going to learn how to do some factoring, how to do some expanding, and then that'll help us translate or transform from one equation form of the quadratic to the other. So remember, just quickly, there's three forms of the quadratic: factored, standard, and vertex. And within the algebra section, we're going to learn how to mathematically do that. I know we were using technology to help us, but we're going to use the mathematics behind it. So we're going to get started, and I want to let you know that for a lot of this unit, folks, the homework will be out of what's called an algebra booklet. I personally feel that the textbook that we have doesn't do enough review from algebra to get us up to where we need to be in order to then relate it to quadratic functions. So we're going to start off with some terminology. It may have been a long time since you've done algebra, or maybe it was more recent, but just to get everybody on the same page, we're going to take time and look at the terminology. Okay, so we have three specific types of polynomials, ladies and gentlemen. One term, if you have one term in the polynomial, it's called a monomial. Okay, and I have a different pen up here. That's interesting. Okay, let's see if I can fix my pen. I'm not sure. Okay, looks like it's fine now. Okay, so a monomial, ladies and gentlemen, an example of that could be 4s, or we could take a look at w to the 5th, or we can take a look at 12.5abc. All right. All examples have just one term, although they may have positives attached to them, negatives. For example, I could put a negative in front of there. It's still one term. Okay, now we're going to take a look at two terms. We have two terms. It's a binomial. Okay, and a binomial, for example, would be something like 3t plus 5. Notice there's two terms. The terms are separated by addition, subtraction, multiplication, or division signs. Or I could have something like d to the 4th minus d to the 3rd. Okay, the next example, ladies and gentlemen, is three terms. It's called a trinomial. Okay, and a trinomial is going to have three terms. So the most common form of the quadratic is ax squared plus bx plus c. That's quadratic form, which is trinomial. And we could have another one, a squared plus 5a minus 6. This is more what we're going to be taking a look at when we do some expanding. We're going to get to that answer, or when we factor, we're going to start with that trinomial. Okay, and again, folks, you want to take a look at these prefixes. Mono means one, bi means two, and tri means three. That's common. If you take a look at a tripod, it has three pegs. If you take a look at a bicycle, it has two wheels. And monocycle is the same as a unicycle. And these are used frequently in science, especially in chemistry, when you're labeling or identifying chemical molecules, chemicals and molecules. Okay, so something like monoglyceride in food, that's another type of prefix, the example where the prefix is being used. All right, next we're going to take a look at parts of a term. Okay, the variable, folks, is the letter that represents a value. You've been doing this all along, ladies and gentlemen. When we say area of a rectangle equals length times width, and you've been subbing in the values for length and subbing in the values for width. So you've been doing it all along. Okay, so examples could be S or A or X or Y. It's the letter. Okay, you can sub it in to represent a value. Now the coefficient, folks, is what's called the number in front of the variable. So a number in front of a variable. Okay, so if I write down something like 3t, it's the 3 part, ladies and gentlemen. Okay, that is the coefficient. Okay, Taking a look at the variable term, that is a term with variables. So a term that has or contains variables. So if I write down something like 3t minus 5, the term that has the variable term is the t in it. So that's the variable term. Okay? And then I take a look at the constant term. That is a term with no variables. It's a number all by itself. So in this example, if I've got 3t minus 5, it's the negative 5 that is, sorry, I tried to change the color here. Let's see if we can do it now. It's the negative 5, folks, that's your constant term. All right, let's keep going here. Example 1, describe all parts of this algebraic expression. Well, first of all, let's identify what this expression is. Is it monomial, binomial, trinomial? And hopefully you realize this is a binomial. Okay, and the binomial is expressed it because we have two terms. Okay, let's split those two terms up. So we know where 3d is the variable term. Okay, and let's split that variable term down. Where the 3 is the coefficient. Okay, that's the number in front of the variable. And d is the variable. All right, so that's the one term. Now let's take a look at the second term. Negative 7. Okay, this is the constant term. Any questions? All right, let's flip to the next page. Just going to move this over, folks. There we go. All right, so now we're going to do things called collecting like terms. Now we have to first examine or remember what like terms mean. So like terms have to share the same variables and exponents. So they have the same variables and same exponents. Excuse me. Sorry, had to sneeze there. So example here, I'll do example 1. So example 1, if I have 4s and negative 3s. Although one's positive, one's negative, they both just have s's. Okay? My second example that I'll do here is like negative ABC, comma 12ABC. Notice they all have ABCs, so you could add or subtract them. Unlike terms mean that they do not have the same variables. Have same variables and exponents. Okay, we'll do a couple examples of these. Okay, so example 1, and the most popular example is, say we have a term that has a and then a term that has a squared. Notice that they have the same variable, but they don't have the same exponent, so those make them unlike terms. And the second example we'll take a look at here is something like 4s and 8t. Okay, they have different variables altogether. All right, let's fill in this box, folks, and this box is important to remember. Only like terms can be added or subtracted, whereas all terms can be multiplied or divided. All right, let's take a look at doing some of this work, folks. Okay? All right, so taking a look, folks, at example 2, it says to simplify. We have for A, it says 4r minus 6r. Are these like terms? Yes, so you can add or subtract them. So you take a look at the coefficients and you say, hey, what's 4 subtract 6? -2, and you leave it as r because they're both r's. Okay? Now, depending on your understanding in grade 9, we're just going to take a look at the like terms in B, and I'll underline them in different colors. So I've got 6b is like or common to -6f is like -3f. Those are two of the same that we can add and subtract. Likewise, the constant terms can be added or subtracted. So in the past, we asked you to group, so I'll start with doing that. So 6f minus 3f gets those two together. Bring the sign with them, folks, okay? And we have +3 and -7, so we put our constants together. So now that we've grouped them, now we're actually going to add or subtract them. Okay, so if you take 6f and you subtract 3f, you have 3f left over. And then you take a look at your constants. 3 minus 7 is going to be -4. Now please notice that these are unlike terms, so we can't do anything else, and we are done. So ladies and gentlemen, in grade 9, we made you show this step. I'm okay in grade 10 if you go from here all the way to here. All right, let's try this next example. Okay, now when you've got two letters, you try to go in alphabetical order. So which one comes first, the W or the X? W, X, Y, Z. So do the W's first. So we know we have 4W minus 1W, so that's going to end up with 3W. Okay, now we take a look at our next like terms, and we have plus 3x plus 4x, which is going to be plus 7x. So if you're wondering where I collected them, just like that. And again, these are not like terms because one has a W and one has an X, so we are done. All right, next example, ladies and gentlemen. Okay, notice we've got some higher order exponents versus some lower order exponents. So the X or the N squareds are going to go together, and we always put the highest power first. Okay, I'll discuss that down in number H. Okay, so if we have N squared and we add 3 more N squared, that's going to be 4N squared. Okay, because that's your base. You keep the bases the same and add the coefficients. And then we take a look at collecting the n. So we got -3n minus 7n is minus 10n. And notice, ladies and gentlemen, these are not like terms, so we can't add or subtract them. All right. Now we're going to take a look at E. So E, ladies and gentlemen, is a little different because you've got to look at your integer laws because we have two signs side by side right here as well as right here. So what we need to do is remember that's kind of like a multiplication. So you have to do that part first before you can add or subtract or collect like terms. So because it's a multiplication. So let's take a look. Leave 4g by itself because it only has one sign, or sorry, -4g by itself. A positive times a negative becomes a negative. So you have minus 3h. A negative times a negative becomes a positive. So we end up with plus 3g. And -6 is a single term. So you leave it as it is. Sorry, a single sign term. Sorry. That was tricky for me to say. Now that, folks, we've removed the brackets, we've applied our integer laws, now we can collect like terms. Okay? So we've got -4g plus 3g is going to be -g. And then our h is -3h minus 6h is -9h. Again, these are not like terms, so we can't do anything else. Okay? Now taking a look at F, ladies and gentlemen, if we have, I want to ask you guys, what's the coefficient in front of that first bracket? And if you say 0, you're wrong, because if 0 times anything is 0, so it wouldn't exist. It's a silent 1. Okay, and it's positive. So if we do distributive law and we multiply everything by 1, it doesn't change anything in the first bracket. However, if we look at the coefficient in front of the second bracket, there's a negative out there. Okay, so you can either multiply everything by -1 or change the signs inside the bracket, because your integer laws will make them the opposite. Just write that in. So change the signs inside the bracket. We did this in grade 9, just making sure you're on the right track still. Okay, so if it's -3r, it's going to become +3r. If it's +2s, that's going to become -2s. If it's +4, it's going to become -4. Now, ladies and gentlemen, we remove the brackets. We've applied any of the distributive laws or the integer laws. We want to take a look at it. And we've done our multiplication, so now we can collect like terms. So when we do this, we take a look at our s's. So we've got 3s minus 2s, which is just 1s or s. Okay, take a look at our r's. It's going to be plus 7r, and our constant goes last, which is minus 4. All right, keep moving along here, folks. We've got g, which is distributive law. Okay, so we're going to multiply whatever's out front with what's inside. These arrows mean to multiply. So that's going to be 12z plus 20y minus 8. And then that's the first bracket. Now we'll do the second sets of brackets. So negative 2 times 8, negative 16, minus 2y, and plus 4z. Once you've done your multiplication according to BEDMAS, you've got to do that first. Then you can add or subtract. So you collect your y's first in terms of alphabetical order. So that would be 18y. Collect your z's, 16z, and collect your constants. You should have negative 24. All right. Taking a look, ladies and gentlemen, the last one, or at h, it's a little harder because the value out front, the monomial out front that we're multiplying, has itself an exponent in it. Or sorry, has itself a variable in it. So each bracket, you might want to break it down into 3 parts, which is the sign. So take this, let's do the first one together. So the sign is going to be negative times the positive is a negative. Now take a look at the coefficients or the numbers. 2 times 7 is 14. And just multiply your variables, which is w, because w times no variable is just w. Let's take a look at the second bracket. Positive times a negative is a negative. 2 times 1 is 2. And w times w, be careful here, is w squared. All right, last term. Negative times a negative, or sorry, last multiplication. Negative times a negative is a positive. 2 times 3 is 6. And be careful here. W times w squared is w cubed. Okay? Remember your exponent laws, folks, when you're multiplying variables of the same base, you add the exponents. And for w to exist, it's got to be to the power of 1. So 1 plus 2 gives you that power of 3. All right? Now, folks, this is something new in grade 10. When you have one variable in your answers, you always want to put the highest power first. So I look here, and this term is the highest power, so I'm going to put it first. So I'm going to go 6w cubed minus 14w minus, sorry, my fault. Back the truck up, my fault, guys. Do the cubed first, then the squared next, which is minus 2w squared, and then minus 14w. Please understand, folks, we're not flipping them from one side to the other, so we don't change the sign. You leave them the same. Now, the reason why we do this, folks, is we always want to talk about having the highest degree first. So I'm going to write something down here called the degree of the polynomial. And that's used in grade 11 and especially in grade 12. Okay. And it's going to be your highest exponent. So in this case, this equals 3. So it's your highest exponent. You always want to put your exponents when you're dealing with one variable first. That's how you write a polynomial in proper form. Okay, so this has a degree of 3. All right, last question, folks, and we're going to focus more on this next class, okay, in terms of multiplication. Okay, it just has 3 monomials, so we're going to do again, break it into its 3 signs. So a negative times a negative is a positive times a positive gives you a positive. So we don't have to write down anything there. Let's do the numbers now. So 3 times 4 is 12, times another 2 is 24. Now we'll do the w's. So w power of 1 to 2, it would be w cubed. And take a look at y's. We have y to the power of 1 plus 2 is 3 plus 6 is 9. All right, we'll be focusing more on that next day, which is to lead into that. And one last thing I want us to do, folks, is called substitution. And we're almost done. All right, so take a look at substitution. What we do, folks, is we replace the variable with the given or calculated value. So taking a look at example 3 here, it says evaluate this expression given that v equals 3 and w equals negative 5. The one thing I want to write in here, folks, is if possible, simplify first. Okay, so can we just write that in here? When you're doing substitution, actually put it right at the top would be better. When you do substitution, you always want to simplify first, if possible. And in this case, it's not possible in ours. Okay? So simplify if possible. Okay, so what we're going to do is we're going to rewrite this expression, and wherever we see a v, we're going to sub in 3, and wherever we see a w, we're going to put in -5. So it's going to be 4 times 3 squared minus 12 times 3 plus 5 times -5 minus 4 times 3 times -5 plus 20. All right? Okay. Use BEDMAS, ladies and gentlemen, so it's going to be 4 times 9 minus 36 minus 25 plus 60. Watch your sign there, folks. And plus 20. Simplifying through, we're going to have 36 minus 25 plus 60 plus 20. One thing I noticed, folks, here is I got a 36 and a -36. Those cancel out. So we end up with an answer of 55. Here's your homework today, folks. Go to page 215, numbers 7 to 11. And next day we'll get into using the algebra booklet that you have. All right? Have a great day, folks, and see me if you need any help.